Georgia's down to 50,000 votes.
Is it now 50,000? Last time I saw it was a difference of 260, I think.
I don't know when they're expected to call it, though. I don't know how much is left. Nevada's the one to watch right now, but they're not supposed to tell us anything more until tomorrow, I guess.
Yeah, I'm not sure what I hadn't done any looking into why they decided they weren't going to finish out their counts until tomorrow. But I know someone that lives in Las Vegas, and she's like, they're all a bunch of idiots here, or crazy. They don't know what they're doing. So I'm not sure what the story is there for real. So.
Have you been to Vegas? Can confirm.
Not recently. I guess it was last year in December. Last time I went to Vegas for AWS reInvent.
Yeah, I've only been there for conferences and things. I'm sure there's plenty of normal people that live there, but the Strip is kind of crazy, for sure. Do you guys have any user group business to go over, or other
The
things?
user group business will basically be us just saying, hey, this is Steve. He's going to talk tonight.
All right.
I had to
Thanks,
get my
keep
video set up so I could see Scott.
Hey Dave, what's your guitar? I see the guitar
It's
back
a
there. What kind?
it's a Yamaha. I've had it for like 25 years.
Nice.
Haven't, just
Oh,
standard four
Dave,
string.
right on. Yeah. Very cool. Sorry
but
for interrupting the meeting. I didn't want to. That's awesome.
Thanks. Nice with your Green Bay hat there.
Yeah. It was one of those, had a production issue about 6 a.m. and I've been up ever since. So,
Oh gosh, yeah.
and I just got off a Packers podcast. I'm sorry, a happy hour. I'm a Patreon supporter for one of the Packers groups.
Ah.
So they just they do a weekly happy hour.
Well, we have 19 people on. I know we're going to have a few more people join on here. We had 28 say that they were going to come in, I think is what it was, if I remember correctly. And we'll just refresh just to see what we had. It was 26, 37. We have 37 that said that they were to show up, but they'll be able to get the video. I'll go ahead and get started. So thank you everybody for joining us tonight at this edition of the North Dallas Developers Group. I'm Dave Penton. I'm one of the officers here, and we're welcoming Steve Smith to speak at our group tonight. He's going to talk about improving the design of existing software. Steve has been around the software development community for many, many years. I've known him for, well, shoot, probably almost 20 years now, Steve. I think it might be actually longer than that now. We'll go ahead and let Steve get started here. As a short note here, we are streaming on YouTube. We posted that in the Slack channel and also have tweeted it on NDD Nug on our Twitter as well. So without further ado, Steve Smith.
Hey everybody, welcome. Thank you. I do see that we're live on YouTube on the North Dallas Developer Group channel, so I'm going to minimize that so it doesn't distract me, but I see they've got 17 subscribers. So if you're watching on their YouTube channel, you should totally subscribe and get them up to at least 20. You can also subscribe to my YouTube if you want. I'm not streaming there at the moment, but I have a lot of stuff from Twitch and other things I throw on there. It's youtube.com/rdallas. It's my Ardallas thing. Some people ask if it's Ardallas or Ardallas. I usually say Ardallas, but I'll answer to either. And so that, it works with North Dallas. That should be easy. But people ask like, well, why do you go by Ardallas? What is that all about? Well, you try being Steve Smith and get an actual user account anywhere with any consistency. There's only about 3 billion Steve Smiths in the world. So I've got Ardallas as a name I used to use when I was playing role-playing games and online games and things. And so now I've just got that everywhere. So usually it's available. I have a podcast that I haven't published anything new on for a little while, but there's a lot of good content there that isn't dated. It's meant to be, you could listen to it anytime, and that's at weeklydevtips.com. That's there. And then I have a blog at rdallas.com along with some other resources. So if you're interested in learning more about me, look for me there or anywhere else as Ardallas. I also have some courses on Pluralsight. I'm just going to get my clicker working. There we go. So if you have a Pluralsight subscription or if you want to get a trial, you can learn more about some of the topics we're going to discuss today. The ones that are most relevant are going to be the 2 recently redone courses on refactoring for C# developers and solid principles for C# developers. You can see links here or just Google for it. I also maintain a Microsoft reference application for ASP.NET Core. It's called eShop on Web. There's a related one called eShop on Containers. The 2 apps, both of them basically have a sample application of an online store that has a catalog of products, and you can add them to your cart, and you can check out, and you can view your previous orders. And they're designed using ASP.NET Core and sort of best practices for separation of concerns and domain-driven design and testability and things like that. My example application, the eShop on Web, is a monolithic app, meaning it's basically a single web application that you deploy. Most applications, I would say more than 90% of applications, probably should be and could be built as monolithic apps. Although microservices, of course, get all the buzz. The eShop on Containers app is about 100 times more complex to do the same app, but shows how to do it all with containers and Kubernetes and a bunch of Azure services and things like that. So look at both of them, see which one better suits your needs, and use those as a reference if you like. There's also this book, Architecting Modern Web Applications with ASP.NET Core and Microsoft Azure, really short, easy to say title. It's a free downloadable PDF ebook that I wrote for Microsoft that goes along with that sample. After today, if the things I'm talking about seem like they'd be something your team would like to learn more about, or you want to learn more about domain-driven design or writing quality software, design patterns, feel free to hit me up. My team and I help developers go faster, help teams build better software faster. So that's pretty much what I do is independent training, consulting, things like that. And if you're an individual developer and you're looking for a group of people that are improving and you want a coach or a mentor to help you advance in your career or go independent, check out devbetter.com, which is a private group coaching program I have. Here's my podcast, which I already mentioned. I am streaming on Twitch for a couple hours a week on Fridays, usually 12 to 2 Eastern time. Here's some of my Pluralsight courses. Recently, they've been having me redo a lot of my older courses to conform with their new branding and video layout and things like that. So a lot of them have been design patterns that I've been updating this year. So these are all the ones you see on your screen right now were all done this year. And then there's a bunch more. Some of them are a little bit older, but still very relevant, like the domain-driven design fundamentals is one of the more popular courses on Pluralsight that Julie Lerman and I did together. We're in the process of redoing that on .NET Core right now. So you can look for an updated version of that in a few months. But if you don't want to wait that long, you can watch the existing course. All the principles still apply. All right. This talk is on improving the design of existing software. And if you have ever picked up the book Refactoring, you'll note that it has a very similar subtitle. And that's what we're going to talk about primarily, is how to identify problems in your code, how to measure them, how to prioritize them, and how to fix them. And because the real problem here is that our software, even though it's just source code, it's just bits that we can check in, it still tends to rot over time, right? Not like machinery does, where there's this chemical process and you have this finely tuned engine, and over time it starts to look like this. But nonetheless, if we take an application and we aren't careful with it, we don't do preventive maintenance on it, over time it's going to be just as useful of a tool as this is, because of the fact that it's rotting over time. So we need to take care of our software by doing maintenance on it. And that maintenance isn't just fixing bugs, but also adapting the design as the application grows and as we understand the design better. So a term that's very useful to understand here is technical debt, which I know most people have probably heard of. It's a metaphor that's been around for a long time. Typically, you have this low quality code that's has to get shipped because of deadline pressure is the most common reason, right? So we don't have time to do it right. We just need to ship it right now. And so you end up getting something that maybe mostly kind of works, but it isn't very clean, and it's not the way you would do it if you had it to do over again. But you ship it, and then it's on to the next deadline, right? And we'll fix it tomorrow, but tomorrow never really comes. And so you end up a lot of times with technical debt, which is this low quality code and shortcuts in our applications. Now, the metaphor for technical debt applies here because just like real debt, there are two components to this, right? There's the principal, there's the amount of time it would have taken to just do the code right or to fix the code now, right? That's the principal. But then there's interest as well. And the interest is what bites you, just like with real debt. So over time, the interest on the technical debt in our code is all that extra effort that we have to go to work around the technical debt in order to fix bugs or add features or adapt the code to changing requirements. There's a good chart that represents this. It's pretty old. This is from 2008, but it's still very relevant. And so there's a few things going on here. So let me just talk about them each individually. the very black dashed line at the bottom is the optimal COC, the optimal cost of change. And so what that represents is that over time, as the application grows, the cost to implement a given feature is going to increase, right? It's going to increase at some steady pace, kind of in line with the scope of the overall app, just because there's more stuff going on. There's more complexity, there's more things to worry about, there's more pieces that might depend on one another. Maintaining an app that's 5 years old is going to be more expensive than adding a new feature to a Hello World app that you just wrote yesterday, right? And then above that, there's a thinner line that goes up sort of asymptotically over time, and that is the actual cost of change. And the actual cost of change is something different from the ideal or the optimal, and that difference is the technical debt. So the interest that you have to pay on technical debt represents itself in that extra cost that it takes for you to make changes to the app over time. And if it's not kept in check, it eventually grows out of control. The only thing you can do if the actual cost of change starts to spike and your customer responsiveness, which is the inverse of that, it's how fast you can respond to requests from customers, that starts to plummet. Basically, the only thing you can do is do nothing and just let the system limp along until your customers abandon it, or replace the whole system, which is very high cost and high risk. If you can act before you get to that point, before it's too late, you can do incremental refactoring. You can keep that cost of change down, and your application can have a long and useful life. All right, so it can be useful sometimes when we talk about technical debt to think about the different kinds there are. And so 2 questions you can ask about technical debt is, was it added to the system deliberately or accidentally? And was it added recklessly or prudently? And with those questions, you can kind of group things into different quadrants and say, reckless, deliberate is, we don't have time for design. We're just going to plow ahead and write whatever code we want and see what works. And so you're like, you probably could have done better. You maybe should have thought out your design or approach a little bit more with some rigor or some forethought, but you didn't. And so you just recklessly introduced some technical debt. Prudent technical debt, it would be, we know we have to ship now. We have a demo tomorrow, or the deadline for the IRS tax day is April 15th. We can't change that, so we have to ship, and we will deal with the consequences. And hopefully you actually do, right? And later on, the shortcuts you made and you correct them, so that it's not a problem going forward. Accidental debt would be where your team doesn't know any better, right? So they don't understand things like separation of concerns or how to use layering to make the code easier to follow or easier to maintain. Or maybe there's prudent but accidental technical debt where the team was well knowledgeable of how to build the software and of the domain at the time, but now the domain has changed, right? And so if we had it to do over again, we might have done things differently, but we made all the right decisions as we went. And obviously that accidental prudent technical debt is the best place for you to be, because it's the best intentioned and probably the least expensive to fix than some of those other kinds of technical debt. This is only useful, kind of after the fact of being able to feel good or bad about how you got here. At the end of the day, if you have technical debt, it's going to slow you down. And so you need a strategy for what you're going to do about that, right? And that could be nothing, and we're just going to wait until the application falls over under its own weight. Or it could be, we're going to adopt some policies of refactoring it and making it better over time, or some variation in between. All right, so preventive maintenance are things we can do to keep our code at a higher level of quality. And some of the things that we can do there, the biggest one, of course, is refactoring. Refactoring, the 2 biggest things you're going to do with that are reduce or eliminate duplication where it's redundant, where it's the same exact concept in multiple places, and simplify the design. So duplication is important to call out, and we'll talk more about that in a little bit, but you don't want to get rid of all duplication, right? You don't want to get rid of incidental duplication. You might have different parts of an application that have duplicate logic or duplicate data in them, but they are going to change at different times for different reasons, and they're not really related to one another. It's just coincidental that they have the same logic or they have the same constant value, right? The number 5 appears in 2 places in your app. That doesn't mean that they're both the same thing, right? And so you don't want to necessarily remove all the duplication, because now you're adding coupling. Right? Anytime you get rid of duplication and you say, I'm going to introduce a new abstraction, a new function, a new constant, and those things that were duplicate, they're all going to refer to that. Right now, all those things are coupled to that new thing, right? And that's not necessarily a good thing, right? It's certainly not free. So you want to make sure that where you eliminate duplications, because really, truly, conceptually, they are the same thing, and having it in multiple places didn't really make sense. You also want to add automated tests if you don't already have them. You want to make sure you're continuing to add them if you have some, but your system is continuing to evolve. These do several things, right? Obviously, they verify that the system works, assuming that you run them and assuming that they're correct. They help you avoid regressions. So when you're adding new features or fixing bugs, they make sure you don't break other things. They also make sure that after you refactor, that your code still does what it did before. With that, they also increase your confidence. If you've been a developer for any period of time or worked on any significantly large system, you might be familiar with this idea of, hey, there's this part of the system that nobody is allowed to touch because the developers that worked on it don't work here anymore, and none of us know how it works, and we're not going to touch it because it might break, and then everything breaks, right? So you don't have any confidence to make changes there, so you literally can't refactor that code. If you had a whole suite of automated tests that told you exactly what that big gnarly piece of code did, then you could go and you could make changes. You could act confidently, run all the tests when you're done, and they all pass and they're all green. You can have some confidence you didn't break anything, and you could continue on, right? And you could start to actually evolve that code that now is sort of a no man's land that no one's allowed to touch. All right, anybody have any questions so far? I'll take a break for a second, grab a drink. If you do, feel free to just post them in the comments wherever you're watching, and the moderators will be sure to let me know. All right, so another question that folks commonly ask is with regard to refactoring and technical debt is, when does it make sense to refactor? A very common thing that teams want to do is have a hardening sprint or a technical sprint or a period of time in which the only thing we're going to focus on for this period is fixing up technical debt. And that's a really hard sell for customers. Generally, when I recommend how you want to refactor, it's more of doing it while you're delivering value, right? Do it along with fixing a feature or fixing a bug or delivering a feature. And there's a story that I really like because it's a good metaphor for this, I think, because your customers, your product owner, your users, they don't really understand software development. I mean, if they did, they might have your job instead of the other way around. And so what they care about is what they can see, right? They care about the external quality of the system. And so they want it to have, good performance. They want it to have a nice user experience, things like that. Those are what they care about. Do they care that all of your code is in one 5,000 line method in the background? Not directly, right? They may care about the fact that it's really hard for you to debug the system now or hard to add a new feature. But that's, they don't know about the source code. They don't see the source code. So try and deliver the stuff while you're delivering value. And then think about this metaphor of a restaurant, right? Imagine that you have a favorite restaurant back when we could go to restaurants and we weren't in the middle of a pandemic. And so like every Friday, you and your significant other, you go to the restaurant, the waiter there knows you, you get your favorite meal, you're happy, it's your happy place, you go there to wind down at the end of a hard week. And so one day you go there for your usual, dinner, and there's a sign on the door, and the sign says, "We apologize, we've had to shut down for the next 30 days because the health department came in and they have a whole lot of problems with how we're doing things in the kitchen. And so we really need to take a technical sprint to clean things up and improve the technical debt of the kitchen space and debug the system." You would probably not be very pleased, right, as a customer. And you would maybe also wonder, like, what exactly is going on in that kitchen that they need to take a month just to clean it up and debug things. That's not going to instill confidence in you as a consumer of food at that restaurant. Likewise, our users, our customers, our stakeholders, as developers, they are expecting that we know how to do our job, that we're a professional, that the software we're delivering is code that has a certain level of quality that's internal, even though they can't see it, as well as external. Just like if you have contractors at your house, doing some work and pouring some concrete or whatever, you're expecting that at the end of the day that code or that work was done in a certain level of workmanship or quality, even if you aren't there watching every second while they do the job. And so you're kind of acting on good faith there as a consumer, that there's some level of professionalism there. You don't want to shake that faith with your customers by telling them that our code is actually a big heaping pile of mud, and we need to go and clean that mess up because we've been making this mess for the last however many years without really telling you, or more likely you have been telling them, but they've been saying, I don't care, we have deadlines, and now we need to clean it up, right? So customers aren't going to take kindly to you suggesting that you need to clean up your mess. They're not going to usually prioritize you cleaning up your mess if you ask them to anyway. So the only time that you're going to get a chance to deliver quality software is if you are just taking responsibility for doing that, right? Don't ask permission to practice basic hygiene when you're delivering your software, right? Surgeons don't ask whether or not you have they have your permission to scrub in before they do the surgery. That's just what they do, right? They don't give you an estimate for the surgery and say, well, I can shave off $500 if I don't have to have any of the instruments sterilized and I don't have to scrub in. Like, they don't even give you that as an option. And if they did, you probably wouldn't want that surgeon, right? So just assume that you're going to have a certain level of quality that you deliver, and deliver it, right? Don't ask for permission. Don't give them 2 estimates and say, well, I could do it crappily in 3 hours, but I could do it right in 5. Like, no, just do the right work as you go. Should be the default. Right now, there are occasions, and we can jump back to that technical debt quadrant here, where maybe it makes sense in a very short term to throw code quality out the window and just produce whatever crap you can and get it done. Those are very rare, right? Those are going to be like, you have an impending deadline and you can't shift it, and the only thing you can do is sacrifice quality for that. But that is not a sustainable position, and if that's the status quo at where you work every single sprint, it's not going to be a sustainable way to deliver that software. All right, so since we can't necessarily fix, yeah, question.
Steve, let me stop you just a second here, because I think someone does have a question here for you, but I think it's very related, so right in the middle of what you're talking about. The question asked is what to do without tests, as technical debt often comes without tests. I have ideas, but would be interested in others. So that, as being the question, sounds very relatable to where you are headed with all of this.
Sure. Yeah. So we'll talk about that in just a minute. What to do when you don't have tests. But the short answer is yes, you're right. Legacy code, which often has a lot of technical debt, is also usually hard to test and doesn't have any automated tests for that reason. And so, what do you do then? You're in this, chicken and egg situation where I would love to refactor it, but I don't have any tests to tell me whether or not I broke everything when I try. So I don't have any confidence that I'm not going to break everything, so I can't get started. And of course, I can't test it because I'd have to refactor it to get it into a position where I could test it. And so, what can you do, right? You just throw up your hands and give up. I have some solutions for that, so I'll get to those in just a minute. Let me talk through this next slide, and I think it's right after that. So a good way to approach software that you want to keep in a high level of quality over time is to follow the Boy Scout rule, which is to leave your code better than you found it. It's named for the Scouts rule of, leave the campground better than you found it, cleaner than you found it. You don't want to have to be responsible for fixing everything on this commit, for fixing this bug or adding this feature, but you could, in the course of fixing this bug, adding this feature, make the code a little better, right? Make the methods that you just had to touch a little cleaner, give them a little bit better names, extract out a method where something was getting a little bit too long, things like that. Basic refactorings you can do as you do the work without having to spend a huge amount of time doing it. And then the code is going to get slowly better as you do that. All right, so it's important to remember that refactoring should not change the system behavior. So by definition, refactoring is an attempt to improve the quality of the software without changing its external behavior. And that's why you have the suite of tests, and the suite of tests verifies the behavior. And then when you're done, it verifies the behavior is the same. You shouldn't have to change the tests in the course of doing a refactoring. If you are changing behavior, you're not refactoring. You're fixing a bug, you're adding a feature, or you're adding a bug, right? Which happens more often than we would like. All right, so now let's talk real quick about the refactoring process with and without automated tests. Okay, so the very first thing you want to do is verify the existing behavior. And that could just be a manual process, right? Depending on what it is you're working on, you might just run through the app and see what it does, right? That could be clicking through and seeing what the different pages do in this response. It could be if it's a some kind of console application, you could run the console and then dump the output to a text file, and then make your changes, and then dump that to a text file after you're done, and then do a diff and see what the change looks like. That could be an approach that you could use sometimes. If you don't have any tests at all, it's useful to write what are called characterization tests. And so characterization tests essentially tell you what the system does right now. and they can be manual. They could be like you run through the process, take some screenshots, record all the things, and when you're done, do it again and compare it with your screenshots. Or it could be like comparing text files or anything like that, right? Does not have to be strictly, unit tests that are automated and perfect, but just something that gives you the confidence that you didn't break anything. If you can, you want to try and test, the code with characterization tests using proper testing methods, right? If the code is in a state where you can decouple it and you can, extract out the chunk that you're worried about from its dependencies and write tests just on that, that's great. But a lot of times it's not there yet, and that's part of why we're refactoring it, is to try and get it there. So until we get there, there's these other types of tests that aren't as automated or aren't as clean as proper automated unit tests might be, but still will give you that confidence that you didn't break the system. Then you want to apply the refactor, to write a test for this method, pass in something to the method, expect the output, and then assert that the output is definitely not what you expect it to be, right? I call the add method, and I pass it the numbers 3 and 4, and I assert that the value is -1. Okay, well, I know it's not going to be -1. Hopefully it's not, right? And so your test immediately fails. And when the test fails, the test output says, hey, you expected -1, but you actually got 7, we hope. And so you just change your test. You say, okay, well, let me change it from -1 to 7, run it again. And assuming that you're not testing a random number generator, hopefully, you get back now the result that you got the previous test run. And now your test is going to run and it's going to stay correct. Unless you break that behavior and change what that method is doing. All right, so that's all it takes to write a characterization test for code that you can easily unit test. Again, if the code isn't in that state, it may take more effort for you to do more manual tests in that case. All right, spaghetti code is one of the things you want to try and avoid. Look out for code that is just this big ball of mud where everything is intermingled. The opposite of spaghetti code is separation of concerns, where you've got different things that are unrelated are each kept in their own separate modules or their own separate classes at least. Things that are commonly teased apart from one another are going to be things like UI concerns, view models or controllers or how you're going to render something, business logic concerns, and then infrastructure concerns and data access or how to send stuff over the network or how to send an email. All those things should be separated from one another in order to make it so that you can easily test them in isolation from one another. And then you just plug them together like Legos, and then you have to test the whole system together too, right? It's not sufficient to only have unit tests, but unit tests are where it's at for the basic logic of each one of these small components. And that's how you're going to get the most bang for your buck on verifying the behavior of your system. All right, this isn't a solid talk, but I do want to briefly talk about the solid principles if you're not familiar with them. I have a couple of Pluralsight courses on this, so that's where I go to learn more. But real quick, there's the don't repeat yourself principle, which is not part of solid, but is sort of fundamental. And then the other 5 are single responsibility, open close, Liskov substitution, interface segregation, and dependency inversion. So the don't repeat yourself principle is an important one that I already mentioned. It's worth repeating that you shouldn't repeat yourself. And so the issue with repetition is that copy-paste coding is the easiest way to be productive today and unproductive tomorrow and forever after that. So, you just want to be real careful about how much you allow copy-paste coding to be the standard way that you add functionality to a system, because it just adds more and more and more technical debt. If you do have repetition in the logic in your system, and it really is the same thing, the same concept that's repeated, it's not incidental or coincidental repetition, then you want to use an abstraction for that to combine those different repetitions into one thing using a method or a class or some other construct that can be referenced from all the places it's used. Frequently, you have duplication in your process. And this is where we're talking about like manual duplication typically. Like, how do we deploy our software? Well, we have one person whose job it is to get all the code and build it on their machine and then FTP it to the server and then remote into the server and extract out the file and blah, blah, blah. All of that stuff that's manual, you want to automate to the extent that you can so that the process is consistent and fast. Basically, anything that's in your process that's hard, you want to try and do it more often. And by striving to do it more often, you will be forced to automate it. And by automating it, you'll be forced to make the implicit explicit and then find any of the problems in that flow, work them out, and have a much faster, easier system. You'll reduce those feedback cycles so that you can ship more rapidly and get feedback more quickly. All right, so speaking about just the duplication in logic and how you can do abstraction, there are a bunch of common refactorings, right? And so when I say refactorings in this context, these are nouns, right? These are specific refactoring techniques that you can use. I talk about them in the Pluralsight course, Refactoring Fundamentals. They're also covered in the refactoring book by Martin Fowler. So things like replacing magic numbers, parameterizing a method. Instead of having multiple different methods, you could have one method that does the same thing, but maybe accepts a parameter. You can pull up fields or methods. What pulling up means is using inheritance and taking things that are in child classes that are duplicated and pulling them up into a base type. You can replace conditional with polymorphism. This is one of the most powerful things you can do in an object-oriented language, is look for places where you've got conditional logic and just completely eliminate it by using subclasses or instances of interfaces to do the work, and then making sure that you pass in the appropriate instance where it needs to be used so that the appropriate type is now going to just do its thing, instead of having to have a big conditional method that figures out, well, if I'm in this type of thing, I'm going to do it this way. If I'm that type of thing, I'm going to do it that way. That's where a lot of bugs creep in, is through those big conditional statements. And you can also introduce a method. So for a concrete example, let's look at something that I see a lot of times in especially ASP.NET Web Forms and MVC code. Later, most ASP.NET Core and later MVC and Web API code maybe tries to use attributes more, but a lot of time you still can't get away from doing role checks somewhere in your code. And so the problem with this is that there's a few things. One, there's a magic string here of admins or administrators or whatever. And if you decide to change that ever, if you have 100 different places where you're referring to that, you've got to touch them all now to fix them. So use a constant for things like that, where you've got a string referring to some unchanging part of your system that's a magic string. The bigger problem here is the fact that there is not an abstraction in place for how this role check happens. So inside this code, right now, today, you've just got admins are able to do whatever. And maybe when you ship the first version of this, there's only 2 levels of authentication. You're either a regular user or you're an admin, right? And so you only have one role, and everything is pretty simple. But later, maybe you get more nuanced, right? Maybe you have managers or you have editors, you have some other intermediate thing between admin and just Joe user. And now you have to go through every single place where only an admin could do something before and evaluate that if statement and say, well, okay, here it still needs to be just an admin, but here it needs to be if it's an admin, or if they're an editor, then they could also do this, right? Now you have to touch all those things again. What you could do instead is use an abstraction for that and get rid of all this repetitive if statements and use something like a privilege type. And so a privilege type basically will specify what a user can do, like can edit or can view or can update or whatever it might be, can insert. Those would be methods that would return a Boolean. And so here you can see if privilege.can edit, then let them edit the thing, right? Otherwise, they can't. So the if statement is still there, but the logic of who can edit what is no longer inside of that controller or that UI level action. Instead, it's been encapsulated inside this privilege. And this privilege can be part of your domain model. It can be part of your business logic. It doesn't have to be tied to the UI level at all. And so you would create a privilege, and it would determine based on whatever you needed to pass it, like who the user is or what roles they're in or what the content item is or the resources they're trying to access. The privilege would then determine, using whatever it needed to, whether or not they should have that access. All right, so this is something that I don't see used very often in most Teams applications, but it can really clean up a lot of duplication inside of those web apps. Another one that's very common is argument validation. So here's one way that you could validate certain required arguments are in place. It's sort of a bad approach because it results in a whole lot of code in order to check that the inputs are correct, but then it obscures the real code. Like right here, this comment that says process the order here, right? That's the real code in this method, but it's totally obfuscated by all this other stuff that's just checking to see if those things are there. So the simplest thing that you can do is use a pattern called a guard clause. And so you can just kind of front load all of the unhappy paths through that method and say, okay, well, if this thing's null, then throw. If there's other things null, then throw. Okay, we got this far, then we're good, right? And so now at the top of every method, you're doing your validation checks. And if the execution proceeds past that, then everything else is good to go, right? You've already checked everything. If it was a problem, it was going to throw, so the process would be gone, and you can trust that now you're good. You don't need to have any if statements. You don't have to have any else clauses. I mean, you have these if statements, but you don't have any nested if blocks, right? There's none of this deep nesting that you have with if statements within if statements. Okay, and then if you want to take this a step further, because there's obviously still some duplication here, another option is to use a library for your guard clauses. So I have one called rdallas.guard clauses. It's extensible, and you can create your own guards. They're just extension methods. But you could say something like guard.against.null on the thing, and then it gives you a consistent experience. So you don't have some developers decide to throw an exception this way and some throw it that way, and it's not consistent. If you use this, it's much easier for you to have a consistent way to do your argument validation. And there's a few other libraries out there you can grab if you don't like how mine does it. All right, so single responsibility principle basically recommends that your classes shouldn't do too many things. They should do one thing, and they should do it well, and they should be encapsulated against change. So Wikipedia basically says your object should have a single responsibility. It should be encapsulated in that class. Uncle Bob suggests that there should never be more than one reason for a class to change, which is another way of saying the same thing. So a common problem with this definition is that people don't always agree on what is a responsibility. And if you don't really know, then it's easy to think, well, I have a customer manager class. It's only responsible for customers. So that follows single responsibility, right? It makes sure that the customer is valid, and it knows how to print it, and it knows how to email the customer any questions that we might have for them. It knows how to get the customer out of the database and save the customer to the database and blah, blah, blah. Like those are all different responsibilities. So examples of responsibilities would be things like persistence, things like validation, notification, error handling, logging, class selection and construction. What I mean by that is deciding who your collaborators are in this class is a responsibility, right? You aren't necessarily the best, this class that you're writing right now, aren't necessarily the best place to decide which other classes you're going to work with. That could be done at a higher level. That could be done somewhere else. Formatting, parsing, mapping, all those things are separate responsibilities that frequently change for different reasons, independent of one another, right? There could be you decide to make a change in how you do logging. Now you have to change every class that knows about logging. That shouldn't be a responsibility that every class has to know about. It should be encapsulated in one location. When you have a lot of extra dependencies, it makes the code more coupled. It means that making a change to any one of those responsibilities is going to have to touch more classes, more parts of the system, which makes it more difficult to make the change. It's a kind of technical debt because it's making it more expensive to implement changes. By breaking apart the code into smaller pieces that each only do one thing, if something has to change for that one thing, it only touches those classes, not those bigger classes that were doing too much. Common refactorings for a single responsibility are things like extracting out a whole class that now does this other thing, extracting a method or moving a method out of a class. Another thing you'll see, I don't know if I have a slide for it on here, I can't remember, but sometimes you'll see a class that has a ton of private methods and not too many public methods. And this can be difficult to test. And it's also usually a sign that this class is not following single responsibility. It's got too many things it's trying to do, and that's evidenced by the fact that it has all these private methods that are trying to do all this stuff. And it's easy for developers, because of that word private, to kind of get hung up on that and think, well, I can't expose any of that logic because it's private. It's secure. I shouldn't make it public anywhere because somebody might be able to get to it. And the idea that it's private, it's only private for that class's public interface, right? It's not private like there's no way we should ever expose this to application developers anywhere in our system. So a very frequent refactoring is take some of those private methods on a class, and especially if you're having a hard time figuring out how to unit test them, right? Put them on a new class, make them all public on the new class, and then just pass that new class into the other one as a collaborator, right? As dependency injected, or as a first option that you could do, just as part of your refactoring, just new it up, right? Instead of calling this dot private method, call new whatever, new instance of this thing that we just created dot that public method, right? It's still going to be private to other classes how the internal workings of the original class are done, right? Nobody else knows that you're calling this other method internally. And if you expose it as a dependency that can be injected in, that's even better, because now it's flexible. And like, yeah, they might know, but also they're in control of it. And so they can swap it out with a different strategy if they want. So taking a bunch of private methods, putting them on a new class and making them public should be a pretty common refactoring that you do, especially if you have legacy code that's violating single responsibility. All right, let's talk for a moment about heuristics and code smells that relate to this. So there's a great coding kata that you can do that kind of helps you practice refactoring as well as writing unit tests. There's a bunch of such katas, but one of them that's my favorite is called the Gilded Rose kata. And it actually has sample code that you start from. Unlike a lot of coding exercises where you start from nothing, this one, you start with a small program that works. And it has this method in it called update quality. And you can get starting points for this in like 50 different programming languages. So, this is using C#, but you can get it in JavaScript or probably any other language you would be using. And just go find it on GitHub if you want the starting point. So the update quality method's job in here is to do all the main work of this application. The application is an online store in something like World of Warcraft with a bunch of items in the store. And every night they run this update quality method, and it changes a couple of properties on all these items to affect their price or their quality. And so there's a bunch of logic based on what type of items are in the store, and they all have different rules for how they work. And so even though this method is only 28 lines long, it has a cyclomatic complexity of 19. And what that means is that there are 19 different paths through this method based on which if conditions are entered into. And cyclomatic complexity is a good thing to check for your methods because it's easy for that to get out of hand. It's easy for that to get out of control. If you look at Wikipedia on this, and I took this screenshot a while ago, so it may be slightly different now, but it basically suggests that whenever the cyclomatic complexity of a method exceeds 10, it starts to get really hard to easily understand what it's doing. And so a good rule of thumb is to keep the cyclomatic complexity at the method level under 10. Now, if we look at this here for just a second, you can see that they're going to give you, this is Visual Studio's tooling. Visual Studio will tell you the cyclomatic complexity of the program is 21, and the whole console is 28, and the whole library is 28. Like, ignore those numbers, right? None of those roll-up numbers really matter. It doesn't tell me anything. If you have an ASP.NET web project and it has a cyclomatic complexity of 500, is that good or bad? Well, it depends, right? It really depends on each method. And so don't worry about roll-ups of that number. It only matters at an individual method level. So for individual methods, try and keep that cyclomatic complexity under 10. Now, you can take that code metric out of Visual Studio, you can export it to Excel, and then you can sort it. And when you do, and the reason why you have to do that is if you try and sort this, it'll do it stupidly like you see here, and it'll sort it based on things like the roll-up numbers, which is not useful because those aren't useful, right? But if you export it to Excel, which I'll show you here, you can change this scope to member, which is just all the methods, and then you can actually sort it on the useful metric, which is member cyclomatic complexity. And so this is an example of some client code that I worked with a couple years ago, and some of their methods cyclomatic complexity, which, you have methods that are 1,300 lines long with 400 cyclomatic complexity. Good luck trying to make a change in there and not break anything. So definitely there's upper limits to where you want the cyclomatic complexity. And look at this, even Microsoft gives us a maintainability index of 0. Their maintainability index is a little bit weird in that even though this maintainability here is below 50, it's on a scale of 0 to 100, right? So if your child came home from school and they took a test and their score was 44 out of 100, you probably wouldn't think that was great, but Microsoft still thinks that's green, right? You're doing a good job. That's just as good as 100. So I'm a little bit not too sure about their color coding on that. It does turn yellow and red, but only if you get like under 20. They're pretty bad on that. But even they understand that a 400 cyclomatic complexity is a 0 maintainability. Any questions about those heuristics? It's pretty easy to run these on your system and kind of get a sense for where they are. If you're looking for a metric that you can track over time for your system, you've got a legacy system, you're trying to improve it over time, you want to be able to track that you're heading in the right direction, or at least not making things worse. A good metric that you can use is called aggregate complexity. And it's basically you take all the method complexities and you divide them by 10 and drop fractions. So anything from 0 to 9 becomes 0. Anything from 10 to 19 becomes 1. All right, and so since we're striving to keep our complexity under 10 for every method, what that means is you have one number for your project or your assembly that you can track, and you can see, is it greater than 0, and is it trending up or down? And as long as you can start trending that downward over time, and you can track that as part of your build process, then you can see that you're pushing down technical debt and things are getting better. All right, so I've got a blog post that you can see here, and you can use an end-depend rule. You can use a pretty simple batch script to do the same thing, but there's ways that you can do this measurement and then tie it into your build process so you can track it over time. right, another code smell that I'm not a fan of are regions. I know some developers disagree and they think regions are great. The reason I don't like regions is because regions are only useful if your code is so big that you need to organize it with some extra construct. And so if you have code that looks like this, you have some method that is so big that the only way to understand what it was doing was to break it up into regions inside the method, then that's telling me right away, hey, this method was too big. They could not understand it, or someone thought it was not understandable without adding these regions to help. And guess what? You know what those regions are telling me? Those are the names of the methods that should have been extracted. And then I could put that logic in those other methods and call them validate input and set properties and save to database, right? And then the code would have been just as understandable from here, but without regions, and the methods would have been smaller and easier to test and easier to understand. You also end up with classes like this, where it's like, all right, what does this class do? I don't know. Usually you end up with code like this where they have so many God classes that do too much that they institute a convention that every class is going to have these organizational regions in them, so that we can quote unquote find things, right? But what it does, it means that you can't find anything unless you open up all the regions, and then they're just clutter and kind of in the way. So if you follow single responsibility principle, regions will just get in your way. If regions are useful, then that's a code spell that's telling you that you're not following single responsibility principle. Okay, so you don't have to follow single responsibility principle, and if you don't, then regions are probably going to help you. But if they're helping you, that should be telling you something. All right. I have a blog post here if you care. So open close principle is the next one of the solid principles, and it states that your code, classes, modules, functions should be open for extension but closed for modification. What that means is that you can add additional behavior to those modules, but you can do so without having to actually change the source code and recompile it and redeploy it. So this is not a new principle. It's been around since the 80s. Dr. Bertrand Meyer referenced it in this book. Some common refactorings to get the open close principle would be extracting an interface and using the strategy pattern. The strategy design pattern, if you're not familiar with it, is basically dependency injection. Dependency injection is super common these days. So if you know dependency injection, congratulations, you know the strategy design pattern. You can add it to your list of patterns that you know. But basically taking a different type and injecting it into another class to change the strategy for how that class behaves, that's dependency injection. That's the strategy pattern. You can also parameterize a method. That's the simplest way to add behavior to a function from the external caller without requiring you to make changes every time to that function. And then template method is another design pattern that can be very useful for this. If you have a process that's fairly consistent and you want to share that process among multiple different instances, and you may add additional versions of that same process in the future, template method gives you a way to allow you to do that without having to have duplication and without having to change the original process's code. All right. So I don't have time to talk about all those different refactorings, but let me talk about one, which is a real simple one, which is just like how to use parameters to change how open close principle can be applied. And most of us get this, but seeing how it applies with open close principle isn't necessarily obvious. So imagine that it's a few years ago and digital cameras are a thing. Our phones don't all just take pictures and store them in the cloud, but I've got to actually take my camera, plug it into my computer, and suck all the pictures off. And so I write this little script that does it for me, and it copies the things and it puts them into a folder called Steve's Photos, right? Because that's my name. And then I think other people might like this, so I compile it into an exe file and I throw it up on my blog and say, hey, download this exe if you want this cool tool to download your pictures, right? And so a whole bunch of people, or 3 people that read my blog, download this thing, and then they run it, and it works great for them, and they love it, and they leave me comments. They say, this is a great tool, but my name's not Steve, and it keeps dumping it into Steve's Photos. What can I do? And so I'm going to be like, hey, it's source code's on GitHub. Go change it, fork it, build your own. And they're going to be like, well, no, I don't want to have to do that. I'm not a developer, right? I don't want to just be able to run this thing. And so the problem there is that this code violates open close principle. The only way to change what that destination folder is as this is written is to actually go in, change the source code, recompile it, and then run that executable. And if you're not a developer, or even if you are, you don't want to go to that effort. Instead, you want to be able to just change the behavior without having to recompile the code. And it turns out it's really easy to do that. If you just pass in a command line argument, pass in a parameter, now you could just call this program, pass in whatever path you want, and it follows open close principle, right? I can change the behavior without having to recompile the code. More likely something you'll see in your business related software is something like this, where you started out with something really simple, but over time, the company kept coming back with more requirements. So maybe originally there was some special customer rule that you had for a given customer, and it might have been really simple. It might have been the very last rule there that said, well, if their income is under 50K and their age is under 30, then return false. Otherwise, they're a special customer. Great. Okay, but now we've also added all these other different rules to that on top of that. And you can look at the source code history and you can see, okay, about once a sprint, somebody comes up with a new rule and they ask us to change this thing, and we have to go in and edit it, and it gets more complicated, gets harder to test. The cyclomatic complexity is obviously growing here with each new addition. So how could we fix this? How could we make it so the open close principle would apply? Well, you could do a very simple rules engine in this case. And so the way that might work is you just define an interface for a rule, and then you create a collection of these rules. You iterate over them and evaluate whether or not the customer, is or is not a special customer or whatever. And if you want to add another one, now you just need to add a rule, right? You don't have to change any existing methods. You just create a new rule, drop it in a particular folder, and let reflection pick it up. Or if you've got a collection of them somewhere that you're managing, by hand, you just need to remember to add it to that collection. But you don't have to change is special customer ever again, because you've moved that logic out into individual rule classes that each follow the single responsibility principle and just do one thing. If you want to learn more about that, this course just came out a month ago, October 8th, and talks about the rules engine pattern. All right, any other questions? Like, take a quick break here.
No questions at the moment.
Cool, thanks, Eric.
You're welcome.
All right, so next is the Liskov substitution principle, which these slides are from a software craftsmanship calendar that my company published a few years ago. And in this case, it's talking about if it looks like a duck, quacks like a duck, but it needs batteries, you probably have the wrong abstraction. So what Liskov substitution principle is all about is being able to substitute a class for its base type, whether that's an interface or an actual class. All right, so it says subtypes must be substitutable for their base types, and this is also from 1988, so it's not exactly new. It's by Dr. Barbara Liskov, who's a professor at MIT. Some common refactorings to fix Liskov substitution are collapse hierarchy, pulling up, pushing down fields, or methods. And basically what is happening here is you have some inheritance hierarchy that isn't quite right. You have some types that aren't really substitutable for their base. Maybe they don't fully implement the interface, or maybe they just need to be treated differently by other parts of your system. And this results in technical debt. It results in extra complexity. Here's an example how you can see this in action. If you ever have some code that ought to be polymorphic, that shouldn't care about what the type of the members are, whether it's a method where it's taking in a thing like an employee as a method argument, or you have a collection where you're looping over a collection of employees or whatever the base type is. And then inside that method or inside that code block, you're checking the type of one of those things. Right? So if employee is manager, not just an employee, but a base type, or sorry, a subtype called manager, that is a code smell. That is telling you that, okay, there's a problem here because this code should no way ever care whether or not any of those employees is this or that particular version of employee. Right? Polymorphism means I can treat them all the same. Liskov substitution principle says that you have to be able to substitute in all of those subtypes for their base type everywhere. Otherwise, you're breaking the principle. And so what this means, and the reason why this is a problem, is that now you get this special case, right? Well, what if we create another subtype? Well, we might have to special case that one too. Well, what if we are referencing employees in more than one place? What if there's other parts of our code that loops through employees or has a method that takes in an employee and needs to do some work with it? Well, we might have to have special cases there too, right? And so this if logic to check, well, what kind of employee is it, tends to spread all throughout the application. It makes it much more harder to maintain. And then when you change something about that logic, you have to go touch all those places, or at least review all those places to verify that none of them need to change too. Anytime you add a new subtype or anytime you change how these rules work, you've got a lot of code all over that you've got to deal with now. You're basically performing shotgun surgery on your application, trying to go find all the spots to make the fix. What you can do instead is just use polymorphism, right? So either let employee know how to print itself and just call print in this example, or let the helper use polymorphism. So it can just take in any employee and know how to print them. right? And it may be that inside that helper, there's a factory that's, newing up an appropriate type of printer for each type of employee, however it's implemented. But for this method right here, the main point is there's no check to see what type of employee it actually is. It doesn't matter. It's an employee, so I can work with it in a strongly typed fashion. It's substitutable regardless of what subtype it might be, and my code is clean and doesn't have any extra if statements in it. Incidentally, C# has gotten better and better about adding support for avoiding problems with nulls, but it's worth remembering that nulls are one of the common ways that you see polymorphism get broken. And most people don't think about it like that, but basically anywhere you're looking for null, it's got the exact same code signature as if you were looking for a type that didn't fit. Right? So when we look at this, we say, well, if the employee is manager, we're going to do this other special thing. Otherwise, we're going to do the default thing. Right? That's the exact same code pattern that you see if they're null. If the employee is null, we're going to do the special thing. Otherwise, we're going to do the standard thing. So look out for that. And there's patterns like the null object pattern that you can use to avoid having to check for nulls. And like I said, you can also use things like a lot of the new C# features that have better support for null, including nullable reference types that are in the latest versions. All right, interface segregation is the next one of the solid principles. And it basically says that you want to have clients determine what their interfaces are, not the other way around. And so your interface segregation principle states that clients should not be forced to depend on methods they don't use. And the corollary to that is that you want to prefer small, focused, cohesive interfaces to big, fat interfaces that could do anything. The most common refactoring for this is to extract an interface. You want to try and keep your interfaces small, keep them focused on one thing. That's what being cohesive is. Think about the task that the user is trying to achieve and have an interface that is like tightly related to that one task. A bad example of interface segregation principle, for those of you that have been around ASP.NET for a couple of years, is the membership provider that shipped with ASP.NET 2.0. If you ever wanted to implement your own custom membership provider and you wanted to do it fully, you wanted to like follow list-of substitution principle and not have a bunch of not implemented exceptions inside your provider, you only had to implement about 172 different methods on this thing in order to get it to work. And it had everything you could ever possibly want to do with membership. There was no separate type or separate interface for, I really just want the user to be able to register, log in, and log out. That's it, which was what 90% of apps needed on the first day. Like later on, they might want some other stuff, but out of the box, you pretty much just wanted to be able to add users, log them in, and log them out. Maybe forgot password comes in, a close, fourth after that. But that's about it. So having an interface that does all this stuff means you're very likely to have a list substitution principle violation because the developer is going to implement just the pieces they need today and not every single method that they aren't actually using. And that means that later on, some other developer is going to say, oh, I can just add this user control to the system that uses this membership provider, and it'll just plug in and it should just work. And when they go to run it, it's going to blow up at runtime and say, oh, not implemented exception. Nobody actually implemented get username by email, even though it's on the type and it should be supported. It's, we didn't need that at the time, so we didn't implement it. So now everything blows up. That's another example of just technical debt that's going to come back to bite you. And it's a result of having this interface that's too fat, right? That you didn't or shouldn't have even been forced to implement the full thing. Another possible example of this that you see sometimes is with repositories, where repositories have a full set of CRUD operations all on the same interface. And what this means is that consumers of this repository always have to depend on all of these methods, even if they're not calling them. And that just matters because every time you necessarily want to change any of this, all those other types are impacted. Even if their method didn't change, they still need to be recompiled. Your change still propagates to those class libraries. If this was deployed as a NuGet package, when they get the new version of the NuGet package, they need to double check that it still works because that type that they depend on changed. Now, this isn't necessarily a bad problem that you should fix everywhere you see it, but one reason why you might want to change it is if you start to think about things like command query responsibility segregation. And if you are going to use CQRS, then it might make sense for you to split your repository into reads and writes. In which case, you might take get by ID and list, put them on an iRead repository, put your create, update, delete on an iWrite repository. And one of the cool things about this is that if you have this existing iRepository of T that looks like this, later on you refactor it like this, as long as you inherit it on your original interface, nothing breaks, right? It just magically works everywhere. It's like binary compatibility is retained. So this type of refactoring is extremely safe to do. And so if you have an existing system that has big fat interfaces and you have some controllers or services or whatever that only need a tiny fraction of those, create the interface you wish you had, right? Create a smaller interface and then pull the methods off of the big fat interface and have it inherit from your small one, right? And eventually you might have a big fat interface that's, you know, really doing like 4 different things, and it turns into an interface that just inherits from 4 other small focused interfaces, right? And so over time, your system starts to use these smaller interfaces that are more cohesive and more focused and gets generally better. And you might even be able to retire the original too big interface at some point. The other reason why you might want to do this split with CQRS is because the types of behavior you might add to data access is usually very different on the read side versus the write side. So for instance, if you want better performance on your reads, it's really easy to take an iRead repository like this and create a decorator for it that adds caching logic and just applies caching anytime somebody asks for something. You'd say, is it already in the cache? Okay, here you go. And that can give you dramatic performance improvements. On the write side, another thing you could do is you can replace those writes with, instead of actually waiting for that write operation to complete, they could be following the command pattern. They could be just writing to a message queue, and then some other process could be picking those things off the queue and actually making those changes later. And so you could scale your system much more, much bigger because of the fact that you're not waiting in proc for every one of those operations to complete as part of every web request to your system. All right, you wouldn't typically do the command pattern though with a get by ID or a list, right? The client's not going to work very well if it says, hey, I need to get this record, and you're like, that's great, I'm going to throw a command on a queue, and you know, some out of process thing will deal with it. Like, but I need the thing right now, right? So those patterns don't necessarily work between each other. You're not going to cache your write. You're not going to cache your update or your delete, right? It doesn't work that way. Now, it is possible that when you do caching, you may also want to purge the cache when writes occur, but you can still do that, you know, even if these interfaces are separate. All right, then the last one is the dependency inversion principle. I would say this is probably the most important of the solid principles, especially architecturally. So I have another talk on clean architecture, and I have a sample on GitHub called Clean Architecture that kind of shows you how to build a system that follows this principle effectively and gives you really easy to test application if you're starting from scratch with a .NET Core app. This principle says that your high-level modules shouldn't depend on your low-level modules. They both should depend on abstractions. When we're talking about C#, when we say abstractions, we almost always mean interfaces. Sometimes we might mean an abstract base class or even just a class, but usually we mean interfaces. Those abstractions, those interfaces, should not depend on details. The details should depend on the abstractions. So what does that mean? Well, details are how the work is done. So the abstraction is, what do I need? It could be something like the iRepository we saw, where I need to get a list of these entities. That's the abstraction. Somehow I want to get a list of entities. The details are, am I getting that list from memory? Am I getting that list from a SQL Server database table? Am I getting it from a file? Where is that list coming from? And I can implement that abstraction using any one of those. But if the abstraction itself depends on the details, then that gets a lot harder. Let's say that instead of my repository here returning an IEnumerable of T for this list, let's say that instead it returns a SQL data reader, right? So now I've got a SQL data reader of customer that I'm getting back from the repository, and I want to wire that up to a file. Well, that's going to be a tough thing to do, right? Because a SQL data reader is expecting to be talking directly to a SQL server through a system.data connection. That's not something I'm going to easily adapt to talk to a file. And so when your details bleed into your abstractions, it makes them much harder to implement and much harder to use for their purpose of decoupling your system. All right, so the dependency inversion principle basically says you want to depend on these abstract interfaces, not on concrete types. Then you want to inject dependencies into classes, have those classes request their dependency through their constructor wherever possible. And then you want to structure your solution so your dependencies flow toward the sender. So outside things depend on the central thing, and the central thing is going to be your abstractions. It's going to be your domain model and your business logic. So this is an example of the ports and adapters, or clean architecture or onion architecture. where at the very center you have your business logic, you have your domain entities, and you have your abstractions and repositories and domain services. Those middle three non-purple circles there, those rings, represent your business layer essentially. And then all around the outside is everything else, right? All your infrastructure, how you talk to the database, how you log to a file, how you talk to an external, REST service or WCF service, all your tests, and your user interface, whether it's a ASP.NET or it's a console or it's WPF. All those things are in the purple region. They're outside. They depend inward on your domain project, not the other way around. And what that means is that it's impossible. Visual Studio won't let you depend on a SQL data reader from your domain entities if that's in your infrastructure project, right? Your SQL repository that's in your infrastructure project, because that infrastructure project is depending on core, and Visual Studio doesn't allow you to have circular dependencies. So it'll enforce these rules for you. All right, so common dependencies that you might have when you're talking about inverting dependencies are things like the framework. The framework you probably just have to take a dependency on, right? That's going to be, are we on .NET or are we on .NET Core or what have you. But other than that, most of these other things you can tweak. Even the framework you can have some control over, right? You can, if you're migrating an existing .NET app to .NET Core, you can use like pre-compiler directives to say, well, if I'm being compiled for .NET, I'm going to call this, otherwise I'm going to call that, right? So even there, you have some ability to tweak it, but it's kind of outside of the source code and the object model at that point. Third-party libraries, you want to put behind an adapter or an interface if you can, something that you own. Don't depend on the third-party libraries interfaces or their abstractions. You want these abstractions to be things that you control. They're part of your domain model. The database, the file system, sending email, talking to external web services, all of those things are obviously dependencies. If your system is riddled with these dependencies everywhere through it, it's going to be really hard to test. It's going to be really hard to change. That's going to make refactoring much more difficult. If instead your system depends on abstractions for all those things, and you can just swap in and out different implementations, swap out a real database for an in-memory database, swap out an in-memory database for a mock that it just returns a list. Those are different choices you can easily do if you've identified those dependencies and abstracted them. It's really hard to do that if everywhere in your system you're newing up a DB context and just talking right to a data store. Things like your clock can sometimes be a thing you want to abstract out. If you are just logging the time or adding the current time to a record when it was created or displaying the time on a web page, then you really don't need an interface or an abstraction for that. It's not changing your behavior, your business logic. But if you have business logic that says, well, I want to notify somebody that this thing is happening, and if it's between 8 and 5 during business hours, I want to notify them through a text message, but otherwise I'm just going to send an email, right? Now you want to do a unit test for that and verify that it's working correctly. How are you going to test that, right? Your test is going to work one way during the week and another way on the weekends. You really want to be able to inject in that date time, either as literally a date time, right? You can just pass the time, or as some interface, like an iDate time or something like that, that then will use whatever you want to pass to it in your tests. .NET code frequently had a lot of static cling to configuration, where you'd see configuration settings.app settings or configuration manager.app settings sprinkled out all throughout the code. That's a dependency that's coupled to now that config. You want to inject that if you can. The new keyword, I have a phrase, new is glue. So anywhere you see something where you're newing up a particular service in your system, you're gluing your current implementation to that other implementation instead of being able to use an abstraction and separate those apart. Same thing with static methods. So you've got this code smell called static cling, where the codes are tightly coupled together because of that use of static, whether it's accessing static properties or variables or calling static methods that have side effects. If you have helper methods, extension methods, static methods that you call that are pure functions, where you have an add function and you call it and you pass it two things and it gives you back a sum, like that's fine. That's not going to make it harder to test. But if you have a static method for something that writes to a database every time you call it, that's going to be a bigger problem, right? Now you can't call any of those methods without having a database for it to talk to. Thread sleep and random are both interesting because you can wrap those in abstraction if your tests can get rid of them. So thread sleep can make your tests really brittle and slow. If you've got something where inside your production code you call something and then you sleep for 10 seconds to make sure it happened and then you check on it, right? Well, your test doesn't necessarily need to do that. Your test could just say, instead of thread sleep, I'm just going to do a no op and then check, what the result is, because I'm just mocking the result anyway, right? If it's a unit test. And so there's no reason for my test to sit there for 10 seconds. I can just mock out the thread sleep if I have an abstraction for it. So that's another trick you can do to speed up your testing. Other things to think about with dependencies are all of the responsibilities we talked about for single responsibility principle. Many of those also are dependencies that you could be injecting in or abstracting out. And so keep those things in mind. They're related, these dependencies and these responsibilities. Common refactorings that you'll do for improving your code to get rid of dependencies are extracting out classes, using the strategy pattern or dependency injection, extracting out methods. And then if you want to, you can introduce a service locator or a dependency injection container if you don't already have one. And it can do a lot of this work for you. Most of your .NET Core systems already have one built in. You've got the service collection that's built into ASP.NET Core. Any of your legacy .NET apps, you could be using AutoFac, Structure Map, Unity, Ninject, whatever suits you. And that can provide you with a lot of flexibility in how your code gets built at runtime. Let's look at a couple examples. So here's some tightly coupled code. For some reason, it's a little bit blurry on my screen. Hopefully you can see it all right. But inside this code, there's some shopping cart and it's got a checkout method. And the checkout method does some stuff and then it sends a message to the user saying, hey, we got your order. Thanks for your order. So what this is doing is it's literally just opening up a network socket and sending some strings over SMTP protocol to a particular server here, localhost, to send this email message. And the problem with that is that this code has some hidden dependencies, right? If you were calling the checkout method and you wanted to test that the other stuff that is commented out here actually worked, you would be blocked from doing so unless you had an SMTP server running on your local machine. And there's no way for you to know that until you try to run this method or you inspect this code by hand. Right? There's nothing in the external interface from that shopping cart class that would tell you that that's the case. And so that's an example of a hidden dependency that you want to avoid. Instead, you want to follow what's called the explicit dependencies principle, which says that your code should be explicit about any of its dependencies it has. And the way it does that is by communicating them through its constructor. So if you have a class that needs to do X, Y, and Z with different types of infrastructure outside of your system, I need to send an email, I need to fetch something from the database, I need to write this thing to a file, I need to log stuff, right? Each one of those things should be a responsibility, a dependency that is injected into its constructor. And so anyone that wants to reference that service should be able to look at that constructor and be like, okay, I've got all those things, I should be good to go, I'll go ahead and use this service. Or they can say, oh, I don't have all those things, I'm going to find a different way to do this. I don't need to use this service. What you don't want to do is have them figure that out at runtime. When they think, okay, I've got exactly the service I need, I'm just going to hook it up, I'm going to call it, I'm going home early tonight, and then boom, runtime is like, oh, nope, sorry, I need this, I need that, I need the other, and you end up going down rabbit holes trying to figure out what all the things are that this thing needs. Going back to that shopping cart, one incremental improvement you could make to it would be to pull out that low-level logic of how to talk to sockets to send an email and put that inside of a helper method. So you could create a static mailer that has a helper method that knows how to do it. And then in checkout, you just call mailer.sendMail. What does that do for us? Well, maybe it means that the only place in the whole system that I know about how to create an SMTP client and send messages is going to be in that helper, right? So I've eliminated a bunch of duplication, assuming I was sending emails in a bunch of places. What has it done for our testability? Not a whole lot. Right? Because it's a static method, I still can't swap it out when I'm testing. And so the only way I can run checkout is still to have that localhost SMTP server running. So that's not ideal, but it is an incremental improvement. It is still slightly better. If someone was doing this as in a pull request and I saw this code, I would say, that's great. You're following the Boy Scout rule. You're leaving the code better than you found it. It's still not perfect, but it's better than it was. I'm going to accept this PR and then maybe next time we'll get around to refactoring it properly. Right, what would properly be? Well, properly would be, I want to extract an interface like I send email. I'm going to implement that with exactly the code that I'm doing currently in this method. So I'm just going to copy paste out those couple lines of code and put them in here. That's my implementation. And then inside the cart, I'm just going to take in an I send email parameter in my constructor. And if before I didn't have a parameterized constructor, what I can do is I can default the functionality here. And I can say, okay, in the default constructor, I'm just going to new up that new method, that new class I just created. Now, inside the checkout method, I can just use this email provider that is the thing that's injected. and it's easy for me to swap out other versions of that. So when I want to run tests, I can swap it out with whatever I want. All right. If you want to learn more about,
there's
there
a question about the dependency injections here that someone had.
Yeah.
If you could talk about perhaps the disadvantages, if there are any, to property dependency injection.
Sure. Yeah, that's a good thing to talk about. All right. So this is an example of what's called constructor dependency injection, and it's still not ideal because of the fact that it has this dependency here. So this would work in a legacy system that didn't have a DI container set up and it wasn't using dependency injection everywhere, but you still wanted to be able to write some tests, right? So this is good to apply as a refactoring to legacy code to make it better. Why is it not still ideal? Well, this cart class now has a direct dependency on this live SMTP mailer class. And that has a few consequences. That means if the cart class is meant to be part of my domain and I want to put it in a project that doesn't have dependencies on infrastructure, well, this live SMTP mailer, that depends on system.net and networking stuff. That's obviously infrastructure. So it should belong in the infrastructure project. Well, there's no way for those two things to jive. Right? This only works if I have these two things in the same project, or if cart is in a project that depends on whatever project this live SMTP mailer ends up in. And so the only way that you can get to that clean architecture approach where you're able to put everything into this core project that doesn't depend on the infrastructure is if you get rid of this. But you can't get rid of this in a system where there's a whole bunch of places that say new cart. Right, so you've got to have a DI container, an IOC container that's newing up things like cart as sort of a prereq before you can get to a really clean state. Now, what about property injection? So property injection would be instead of requiring this thing to come in through this constructor, maybe I still keep a parameterless constructor that doesn't do anything, or it has this default in it. But if I want to override this behavior in my tests, instead of making this thing private, I could make it public as a property, and I could set it to something else. And then I can, if I don't want this dependency on this type, I could get rid of this, don't have any default at all. And then inside my code somewhere, I could do a check and say, hey, if the email provider property is null, throw an exception that says you must set the email provider property before calling this method, right? So the developer at least knows. Okay, so the problem with property injection, the reason why I don't recommend it as the default is that DI containers don't just do it by default. And what I mean by do it is, when you go to create this method, or sorry, this class, this cart, what your IOC container is going to do is it's going to look and see if it knows how to create this thing. And if it doesn't have any dependencies, then it's like, great, I'll just new it up. But if it has dependencies, like in this case, this iSend email thing, then the next thing it's going to do is it's going to say, oh, I need an iSend email interface. Do I know how to build that? And if it does, then it'll go find an instance of what it needs, this live SMTP mailer, and it'll check it for any dependencies, and it'll go on up the tree recursively until it has managed to build all the things it needs. If you use property injection, it doesn't do that the same way typically, most containers. So you can still get it to work, but it's a little bit more manual than this. And it also doesn't communicate the intent as effectively, right? Presumably most of your things have a lot of properties. They have various properties for things they do. Oh, and there's also this property that's a dependency that you have to set in order for the thing to work. Like, how do you communicate that intent? Constructor already communicates that very well. You can say, I don't have any constructor except this one, and this one needs these three things in order for you to create an instance. That communicates intent beautifully, and it makes it really hard for developers to do the wrong thing, right? They literally can't create the thing, short of reflection, without doing what you're asking and knowing the things they need to pass in. The other problem with property injection is that it's possible, and in fact, it's likely, that that instance is going to be in an invalid state for some period of time during its life. And so it's possible that things might call it while it's invalid, and that will cause bugs, obviously, right? It'll have null reference exceptions or behavior you don't expect. Maybe it has a default provider, and you're going to set it to a different one. So someone forgets to set it to a different one, and now you're using the default provider some of the time. And then later on in its life cycle, it does get the property updated. And now for another part of its life cycle, it's using a whole different provider. How's that going to be easy to track down as behavior when the system's doing like different things at different times for who knows why? So those are sort of the reasons why it's less recommended. It can still work, and it's still, if you're in web forms, property injection is actually a good way to get DI, dependency injection, in web forms, because you can have a base page class that has properties for any dependencies you need, And then you can tell IOC containers like structure map that anytime a page gets created, go find all of its property dependencies, new them up, and populate them, right? And so as part of the construction process of a web form page, your IOC container could be doing that for you. But that's because web forms isn't designed for DI, that you have to do sort of workarounds like that. In .NET Core, it's designed from the ground up for DI. So everything expects constructor-based dependency injection. Everything in the framework already uses it. So there's no reason why you shouldn't use it typically in your system as well. Two other ways to fix this that I should mention is method level injection, right? So I could have just changed checkout. So instead of taking no parameters, it actually took in an email provider, right? So if you have a dependency that's only used by one method, you could say that the method is going to take it. The biggest issue with that is that you're just kind of moving the goalposts, where now the caller needs an instance of that thing. Well, where does the caller get it? Well, they could new it up. Okay, but now we have the same problem that something is having to new it up. Well, they could ask for it in their constructor. Yes, but why didn't we just ask for it in this one's constructor? We're just pushing the dependency further away from the thing that actually needs it. So you can, and sometimes it makes sense, put it on the method signature, but it's not free, right? It's not without downsides. And then the last option is the service locator pattern. Service locator pattern is basically, I'm going to create an instance of my container here, or I'm going to have a static instance of my container. And then anywhere I need something, I'm just going to ask the container for it. And I'll say, container, give me an email provider right here. And so it's sort of like this global factory that you could ask for things anytime. It's got a lot of problems if you use that throughout your system that I don't have time to get into. But if you Google service locator as an anti-pattern, you'll see there's a bunch of reasons why you don't want to use that as your default, your go-to way of solving this problem. It is useful to know that it's a thing that you could use if nothing else works. And sometimes it is the best solution, but it shouldn't be your default solution. Hopefully that answers that question, probably more than you were asking for.
That's always a good thing.
And actually, I think I am close to the end. But I don't want to overstay my welcome here and go past everyone's attention span. So if you would like to learn more, here are a bunch of resources. You can contact me through my website, ardallas.com, or find me on Twitter and elsewhere. So if you want to learn more about these things on Pluralsight, these are the 3 courses that are probably the best to look at. And I already mentioned DevBetter and a bunch of other resources at the start, so I won't go into that. I have time for as many questions as folks may have. I have a few more slides I could talk about just general quality for the industry. So if folks want to stick around and talk about that a little bit, I'm happy to. But other than that, this was the main point that I wanted to get across tonight, and I hope it was valuable to the folks that were here this evening.
If anyone else wants to pop any questions in the chat, that'd be fine as well.
All right, let me talk for a couple more minutes. I've got like 5 more slides on quality that I wanted to share, and then I'll call it a night. So this is sort of like a mini keynote thing that you could do at a tech conference if those were still live events. But the idea here is talking about quality, talking about improving quality of your system. If I ask a big room full of developers, typically, which one is faster for you? Writing code that you're not really happy with, the quality of, but that you can get something to work, or writing code that is good, what you consider good quality code. Almost everybody is going to say, I can write crappy code faster, right? And then I'll clean it up later. But some developers, especially a lot of folks that do TDD, for instance, will say, I would write the test first code as the default way to go fast, because I know I'll save myself time with debugging and trying to track things down and all that other stuff on the back end. As the system gets more complicated, those tests are going to make me faster, not slower. And so there's a difference there, right? And I think there's more and more developers that are in that second camp that understand that doing things, sort of a slow and steady wins the race approach of building the quality in up front so that you can go fast, so that you can maintain that speed. And so in the industry, if we continue to ask people these questions, what does it take to get more people to be in that second camp, to be in that camp where you can actually go fast by default. You know, and why, if you answer this question one way or the other, why is it that you answer it that way? What is it that makes you think the way you do? What in your experience or in your skill set has led you to that conclusion? So how can we develop our skills, our tools, et cetera, so that the natural path, the easier path, is to build stuff right, to build stuff with higher quality, and to make that easier than doing it the crappy way, where you don't have testable code, you don't have easy to maintain applications, and eventually things get worse and worse and worse until we can't maintain them. So we sort of visualize these two approaches, and we graph them over time. And we say that, you know, let's say the vertical y-axis here is user stories being completed, and the x-axis is time. So if we're saying that I can do high quality code at a certain speed, a certain velocity, and complete these stories, but it's slightly lower than how fast I can do low quality code. But low quality code, we already saw from the technical debt charts that I shared earlier, over time, low quality code starts to incur interest from that technical debt. And it's not immediate, right? You don't usually feel it in the first month or two, but over months and years of an application, you'll definitely start to slow down as a result of technical debt. And most developers would rather work on a greenfield development project than a legacy project that's been around for 5 or 6 years that all of its original developers have abandoned, for really good reasons, right? Because that code, the legacy code, is usually a big ball of mud, pile of mess that nobody wants to work on, and nobody knows how it works, and you can't test it. And that's because of that technical debt. So all we really would need to do to make this change, to make it so developers would be able to write the high quality code by default, is slightly increase that slope. All right, so that, you know, as that slope goes up for that blue line, if it gets up to the point where it's in line with the low quality version and it doesn't fall over because of technical debt after, you know, a couple of months, now we've achieved that goal. So I think that with, you know, better tools, better education, developers taking the time to practice things like testing, writing solid code, learning how to refactor as just a matter of course, having the professional discipline to not ask for permission to write code the right way, but just do that because we're professionals. I think that we could start to do that as an industry. And I think that we need to do that as an industry, because it will become, you know, a bigger and bigger problem if our code continues to have such low quality that users can't trust us. And we'll start to have more and more issues with licensing and bureaucracy, lawsuits, legal liability for the problems that we introduce in our code if we aren't more conscious about the decisions that we make and how we choose to develop the systems that we build. So that's all I've got on that part. Does anybody have any comments, feedback, questions? What do you think about that? You know, do you agree? Do you think that it's possible for developers to build high quality code as fast as or by default versus low quality code? What's your take on that? Anybody?
I mean, I'll throw something in. Oh, go ahead, Russell. Go ahead.
That's fair, and that's a common straw man argument that folks will make, is like, well, the only reason why there's any value in using an abstraction is if we were going to change our database, and really, how often does that happen? And sure, like for most apps, it doesn't happen all that often, and if it does, it's kind of a big deal. But that's not really the reason why we're following the dependency inversion principle, right? So that's why it's a straw man argument. Like, what are the chances that you might want to add some behavior to how you talk to the database? What if we want to add caching as a decorator? oh, well, we used an interface for that. Well, it's trivial to add a decorator design pattern to an interface. It's really hard to do that if you're just directly writing SQL everywhere in your code that you want to talk to the database. So, there's all kinds of other design benefits, even leaving aside testing, even leaving aside flexible choices of what absolute provider you're going to use, that you get as benefits. So yeah, next time you're in that argument, just ping me, DM me on Twitter, and I'll jump in and hopefully help out.
So on a similar note, another member had asked basically how would you deal with this advocating for this diplomatically, which I think is similar to what you were just discussing. Another user responded with, one reason someone might avoid TDD is because they want to get their app written before the technology changes under them, or that they want to just get their app out there. And time to market, time to delivery is definitely an important point to consider.
If you're not good at TDD, then yes, it might take you a while to skill up, and get the skills necessary to do TDD, right? You have to learn how to write unit tests and how to use your testing framework on whatever platform you're doing, and then how to run them and how to build an automated pipeline that runs them and all those things. Like, if you don't know how to do all that, then yes, it'll impact your time to market because you got to learn all that stuff, let's say, either in parallel with building your app or before you start building your app. Neither one of those is going to help you be faster in that very short window of, oh my gosh, I have this idea, I must get to market first. Most of the time, you're only going to have to pay that price once, right? So if you learn at age 20 how to do testing and automation and TDD, then the rest of your career, you know how to do that, right? So it's one of those things where the sooner you learn it, the longer you're going to have the benefits of it. It's an investment that pays off in the long run. But even in a relatively short period of time, if you're writing an application that has any degree of complexity to it, or will have by the time it's really being used, it's not going to be a bad thing if you're able to refactor that app, because the framework is going to change out from under you, because you're now going to want to ship it as a mobile app in addition to a web app or whatever. Right? There's going to be other changes that are going to come along if you're successful. And if you're not successful, you're going to throw it away anyway. So there's that argument for, let's just write crappy code, because if it doesn't work, it's not going to matter. We're going to throw it away. So all these problems are only a problem if you're successful. But if you're successful, those tests are definitely going to be a benefit to you, because when it comes time now to scale up to all those wonderful users that think you're great, you're going to be able to do that better when you've got tests that show how the system works, so you can refactor it and change how it works.
Does anyone have anything else?
I don't think I've worked on a brand new app in about a decade at this point, so it's hard for me to say.
Did any of this resonate with you then?
Well, whenever you jump into an existing large old application, at that point, yeah, a lot of the other stuff certainly applies. But simply the question of, all right, would it be faster for you to move forward while doing things exactly right? That's a different kind of thing in a new application, or at least in a relatively small application, than in a really large sprawling application that has lots of bugs everywhere.
Right.
So
something I didn't
just
mention.
different kind of situations, I mean, the whole first part of your discussion was very much fitted for that kind of application, which is where I'm living right now, and which is okay.
Yeah, something else I wanted to mention, I thought I had a slide for it, but I just realized I didn't, is that when you're working on an application, whether it's legacy code or an app that you've just been building recently, if you have the choice between adding additional complexity to an existing method or adding code to a new class with a new method, most of the time, especially on that legacy code that's not well tested and that you're having to deal with a poor design, you're better off to do your new functionality in new classes. And the reason why is because when you decide you're going to create a new class for this functionality, it frees you up from a design perspective immensely, right? Nothing else in the entire system is calling that class yet. because it doesn't exist yet, right? So you have no dependencies to worry about. You're completely free to design it however you want. You want to be able to unit test it, do so, right? You want to have dependency injection, you want to pass things to its constructor, knock yourself out, go for it. You want to practice some new pattern, okay, right? It's brand new, do whatever you want. The whole class is, you know, your playground at that point. Now, how do you use that logic? Well, the method where you were about to put that extra code, that one extra if statement that's inside 10 nested if statements, instead of putting that code right there and new up this new class and just call a method on it, right? And then put that code that you were about to put, now it's in this other class. And now it's unit testable, right? Test the heck out of this class. And it does that one thing and it does it well and you know it works. And over time, if you follow that approach, classes that generally start to follow solid better, right? They're going to be single responsibility. You're going to have smaller classes. You're going to have more tests. That big ugly method, maybe start extracting some things out of it into these other classes. And the system starts to get better over time, that worse.
Someone commented that it sounds like event sourcing.
Not sure what they were referring to.
Robin, would you like to expand on your thoughts there?
Robin sounds like events. Yeah.
Yeah, Robin, if you want to turn on your microphone or whatever, that'd be fine too. If you wanted to, adding new functionality but preserving old code.
Okay. Maybe. Yeah, I don't know. I don't have a huge amount of experience with event sourcing. I think of event sourcing as doing like inserts only for data, and then figuring out what the current state of the thing is based on all the previous history of that data that's changed. I don't know that adding new classes to the running code is totally analogous to that, but I can see how it is like add only, right, as opposed to update. So I get you where you're coming from there. That like we're going to just add code instead of changing the existing code. So I think that's what you're going for with the metaphor. I think yeah, that works. Cool. I got there. I was a little slow. Oh, thanks, John. Glad to hear it. Mm-hmm. Mm-hmm. It sounds like your team values just getting the minimum bar done and moving on, and doesn't necessarily value having quality code at the end of the day. And so for that, like, you know, different teams have different values, right? And maybe what they value, what is working for them, right? If you have an organization where let's just say, for instance, I know companies that are like this, that are contract companies. I don't know anything about your organization or what you work at, but I know some companies where they get lots of small businesses asking them to build small websites for small amounts of money, and they need to turn them around quickly. And so, you know, they are not really interested in clean code or maintainable code. They're interested in, we did a fixed bid on this. Our margins are on the line if this takes more than the minimum amount of effort. Just get this stuff done, and we've got another one waiting for you tomorrow. And so that's a different, you know, business model, and maybe that is the right approach for that business model to do. But if you're working in an enterprise that has an application that's expected to have a shelf life that's measured in years, not months, and you're expecting that next sprint and the sprint after that and the sprint after that, you're still going to be maintaining the same app and you're still going to be adding features and fixing bugs, then it makes sense to take a little bit of a longer term view and not just try and sprint through every bug fix. and not worry about the fact that you've left the code a mess when you were done. Most restaurants, most kitchens, you hope, are cleaning up the kitchen at the end of the night, if not after each meal, right? Each busy period. If the kitchen never cleans up, because who has time for that, right? And it's just a total mess, then eventually it's going to come back to bite you, and you're not going to be able to continue as a restaurant, right? The health department's going to shut you down. So no, you didn't have to clean up your workstation as part of being done with doing this work, but you should do it because it's what professionals do. And making the code better is obviously going to make the code better. That's what the word means, like over time. So at the end of the day, it's like, well, you can try and educate them, and if they're your superiors, that becomes more difficult. Sometimes you can manage up, but not always. But at the end of the day, the quote that I like is, you can change your organization, or you can change organizations, right? And that's sometimes where you end up.
So one thing to expand on your metaphor of a kitchen, and a chef. Yes, if you clean your workstation after you're done preparing a dish, that's certainly part of what you need to do. You don't have to. You can prepare another dish on top of it, but it's probably better if you do. Then again, you may not take the time out to go like restock some shelves somewhere that could be restocked later on.
Yeah.
I don't know. I mean, depends.
Metaphors are not perfect, right? And there's
Right.
certainly stuff you could do that would fall into the category of just gold plating, right? Like, oh, you're just gold plating your code. You're not, it's not really needed for what we're doing. Usually when you're trying to refactor something, following the Boy Scout rule, looking at stuff, it should be relatively simple things, right? It should be like, I'm renaming this, I'm extracting out this method, I'm doing something that perhaps is making my job easier to implement this feature, right? Like right now, if I need to implement this feature, I need to touch 3 different controls. They're all doing the same thing kind of differently. Let me just extract that out into one common abstraction, get that working, make sure that's all good, and then make the change I need that applies to all of them. Right, and then put that in as one commit, as one pull request. Like now someone can look at that and they could say, well, why, Steve, why did you make these other changes? Why did you introduce this new thing to do this? And I could tell them, like, it made it so that the actual feature was easier to actually deliver. I was more confident that it worked. It was easier to test. And next week when we have a similar change, it'll take 5 minutes instead of an hour. Like, pretty easy. So, it's there's some art to it, right? It's going to be based on your team's priorities, your business's priorities, things like that. It's and because it's leave it better than you found it. It's not there's no amount there, right? As long as it's any little bit better, it didn't get worse. You're just trying to hold the bar, right? So that it's moving in a positive direction and maintain some momentum toward better quality, so that you're not just constantly falling into more and more technical debt. And so just by shooting for that low bar, it should kind of help you keep the code somewhat better. You could clean it up a whole lot, but that's not always the best use of the business's time and money. And I recognize that. So be pragmatic about it, but be able to justify, like, no, this change improved the quality of the code and helped me get this work done better.
And so some of the comments that we still have here, Mike Randrup, yes, thanks. Very helpful to see your presentation. Then we have extending on Russell's question, refactoring means more than regression testing. Hard to justify to management for the extra budget when budget is tight.
Right, and that's possible. Although if you were changing the system anyway, you were going to be doing that regression testing anyway, right? So, it depends on what the refactoring is. So if I'm talking about, I've got a change that I need to make and it affects these 2 classes, and right now these 2 classes work a certain way, and like this one's doing way too much, and I can move some of its functionality into this other class, and I had to change both those classes anyway, no matter what. I don't think that adds a whole lot of extra regression testing. Like I still was changing those things, still was going to have to run those regression tests. All I'm doing is making it so the code is cleaner. The regression tests don't even know whether or not the code was cleaner. They're just proving to me that everything still works. Yeah, and then Paul had another comment too.
Sure, it looks like so in my experience, TDD really shines when updating a tricky critical method, which is high risk. It takes a lot of pressure off knowing it has passed a bunch of tests. Just need to make sure that the runtime context is the same mostly. which
Sure.
that makes a lot of sense.
Sure. Yeah, and he's saying you want to make sure that the tests apply equally in production in the runtime context as they do in the test environment, because otherwise your tests aren't necessarily helping. And yeah, that's what I'm talking about earlier in the presentation when I was talking about giving you confidence, right? You have some tests, they make it so that you're a lot less stressed about whether or not you just broke everything when you think about doing a refactoring. So you're more likely to do it. You're, and like the other comment was suggesting about regression testing, like if you have a whole suite of tests, automated tests as part of your application, you're not relying on, let's say UI-based automated tests, or even worse, manual tests from QA or from customers doing a lot of regression testing to check things for you, right? That is a very expensive and high risk thing that you want to avoid. So if you have a big extensive suite of automated tests that you can run quickly and easily before you even check your code in, then you have a lot of confidence that it's not going to be something that's going to introduce a regression that's going to be discovered later on in the development pipeline.
Does anyone have anything else? I mean, it looks like we could probably close it up now. I'm sure that it's 9:15 where Steve is now, and probably after bedtime for your kids, I think, at this point.
Some of them, yep.
Yeah. So thank you very much, Steve, for taking some time out tonight and spending it with us. This is a great presentation on talking about making better code and better testable code. And Steve is on Twitter. On his handle is Ardalis. He's very active on Twitter. He'll definitely have a conversation with you out there. Again, thank you so much, Steve. Really appreciate you joining us in the North Dallas Developers Group. And Eric, would you like to? Is there anything else you'd like to say, or any of the other officers on?
I don't think so. Thanks for coming, Steve. Really appreciate it.
You're welcome. Thanks for having me. Looking forward to maybe visiting in person sometime once we're past the whole COVID pandemic.
That'd be great.
Oh yeah. All right. Well, we'll call it. We'll call it now. Have a great evening, everyone, and stay safe.
Thanks.
All right. Thank you, Steve.